Back students, in the previous lecture we have discussed about the fundamental forces, and we have already discussed about two of our fundamental forces. First one is gravitational force and another one is electromagnetic force. Now we are going to discuss about our next fundamental force, that is strong electromagnetic force. Strong electromagnetic forces are those forces which binds the nucleons inside the nucleus, or we can simply say that a force which binds the proton and neutrons inside the nucleus is known as strong nuclear force. Let's write down its definition. A force which binds the nucleons, that is proton and neutrons inside the nucleus are is known as strong nuclear force. Okay, it is attractive in nature. If we talk about the nature of the strong nuclear force, it is attractive in nature, but if the separation between the nucleons decreases about 0.5 fermimeter, then it will becomes repulsive. Okay, it is the property of strong nuclear force that it is attractive in nature when the size is comparable to the fermimeters, approximately 1 fermimeter. Then the forces between the proton and neutron will be attractive. But on the other hand, if the separation between the proton and neutron decreases to 0.5 fermimeter, then the force of interaction between them becomes repulsive. As the name suggests that it is a nuclear force, and nuclear force occurs due to the I'm discussing about the properties here. Properties, and the nuclear forces occur due to the exchange of pi mesons. Exchange of pi mesons means these are the exchange particles in case of strong nuclear forces. Okay, as the name suggests, these are the nuclear forces, and the size of nucleus is of fermimeters. So it is a very short range force. It is a very short range force. Short range force. Because the range of the strong nuclear force is too small. And next one is, it is non-central and non-conservative force. It is non-central and non-conservative. ना तो ये सेंट्रल फोर्स है और ना ही कंजर्वेटिव फोर्स है. मींस इनिशियल और फाइनल पोजीशन की बजाय ये किसके ऊपर डिपेंड करता है, पाथ फॉलोड बाय द बॉडी के ऊपर भी डिपेंड करता है. एंड इट वेरीज एज द हायर पावर्स ऑफ द अर्थ सेपरेशन. इट वेरीज इनवर्सली with the higher powers of distance, that is r is greater than 2. Okay, higher powers of distance, that is r is greater than 2. Next one is our weak nuclear force. Okay, now we are going to discuss about the next fundamental force, that is weak nuclear force. This is we have remained with the last property, the last and main property with the strong nuclear force, that strong nuclear forces are these forces are 100 times stronger then electromagnetic forces. Electromagnetic forces. And 10 raised to power 38 times, 10 raised to power 38 times stronger than gravitational forces. Gravitational forces क्या रहते हैं? 100 टाइम्स स्ट्रॉन्गर रहते हैं किसे? इलेक्ट्रोमैग्नेटिक फोर्स से, और 10 raised to power 38 टाइम्स स्ट्रॉन्गर रहते हैं ग्रेविटेशनल फोर्सेस से. Okay, so these are the properties of strong nuclear forces, and let's start with our next force, which is known as weak nuclear force. It is weak by name only. Okay, not too weak. As we know, the weakest force in nature is gravitational force. So it is also stronger than the gravitational force. Let's discuss about this force. Weak nuclear forces. Weak nuclear forces, these forces appears between the elementary particles, between the elementary particles involved, elementary particles involved in a nuclear reaction or process, like beta decay, like beta decay. क्या है? वीक न्यूक्लियर फोर्सेस क्या रहते हैं? ये सिर्फ एलिमेंट्री पार्टिकल्स ऐसे पार्टिकल होते हैं जिनसे मिलकर के हमारा एटम या फिर कोई भी मॉलिक्यूल बना होता है. सो जो वीक न्यूक्लियर फोर्सेस रहेंगे, कौन से फोर्स रहेंगे? जो एलिमेंट्री पार्टिकल्स के बीच में लगेंगे. और एलिमेंट्री पार्टिकल्स भी कौन से होने चाहिए हमारे? जो किसी न्यूक्लियर प्रोसेस के अंदर इन्वॉल्व हो. जैसे कि हमने यहाँ पर एग्जांपल लिया है बीटा डिके का. बीटा डिके एक ऐसा प्रोसेस है जिसमें क्या होता है कि हमारे न्यूक्लियस से, किसी भी एटम के न्यूक्लियस से इलेक्ट्रॉन बाहर निकलता है, और साथ में एक एंटी पार्टिकल जिसको हम न्यूट्रिनो बोलते हैं वो भी साथ में निकलता है. और जो बीटा पार्टिकल है जिसको कि हमने इलेक्ट्रॉन नाम दिया है, तो जो इलेक्ट्रॉन और न्यूट्रिनो के बीच का जो इंटरेक्शन रहता है उसको हम क्या बोलते हैं? हमारा वीक न्यूक्लियर फोर्स बोलते हैं. ठीक है, द इंटरेक्शन बिटवीन द इलेक्ट्रॉन एंड द एंटी न्यूट्रिनो इज नोन एज द is due to the weak nuclear force. It occurs due to the weak nuclear force. And here, as we have discussed that there is always a exchange particle present. Here the exchange particles are bosons. Exchange particles are bosons. In case of strong nuclear force, the exchange particles are mesons, but here the exchange particles are mesons. The weak nuclear forces are also the of short range forces. These are also short range forces, because it is of the order of 10 raised to power minus 15, approximately greater than sometimes just outside the nucleus they start acting on the elementary particles. Okay, the order of the weak nuclear forces is 10 raised to power minus 15, greater than 10 raised to power minus 15. Okay, and it is also stronger than the gravitational forces, but weaker than the electromagnetic force and strong nuclear forces. It is 10 raised to power 25 times. It is 10 raised to power 25 times stronger than gravitational forces. forces. If we take the ratio of gravitational force, strong nuclear force, weak nuclear force, and electromagnetic force, then so I am representing here Fg by Fg is used for the force of gravitation, and F W F E and F S. Here Fg is the gravitational force, Fw is the weak nuclear force, and Fe is the electromagnetic force, and Fs is the strong nuclear force. Then the ratio will be equals to 1 ratio 10 raised to power 25 ratio 10 raised to power 36 ratio 10 raised to power 38. This ratio is often asked in your competitive exams, so you have to remember this one. So these are our fundamental forces. In the next video we are going to discuss about the conservative laws. So guys, you have to study carefully. Thank you.